Brian Purdy with the Florida Aviation Network. Today, we're going to have the opportunity to talk with Mr. Aleksey Matyushev. He is the CEO of Natilus. They're working on a blended wing body design for cargo aircraft. So we're just going to go ahead and start that conversation. Thank you for joining me, Aleksey. Look forward to hearing about how your company is growing and your background and how that started.
Thank you so much for having me on board, Brian. Appreciate it.
Yeah. So I've only seen your website a little bit. And I've been around the B2, so that's a flying wing, but this is a little bit more efficient design using the blended wing. What other advantages do you see with that blended wing? How is it going to improve cargo operations?
Great question. So as I'm sure we all know as aviation enthusiasts, the blended wing body design has been around for some time, but we just can't figure out a purpose for it, as well as the timing doesn't seem to ever work out. And so what we saw when we started the company, a couple of really, two fundamental trends going on in the cargo industry. And so we thought that the blended wing body would be a really great solution for that. The first one is the realization that it's really volume, not weight, that drives air freight today. And it kind of makes sense. You open up an Amazon box, it's halfway filled with air. And so as customer expectations are encouraging almost instantaneous deliveries of these e-commerce products, air freight is starting to play in a more important role as far as that ecosystem goes. And the second key piece of the puzzle is the sustainability goals. So a lot of these airline customers have very aggressive sustainability goals, for whether it be for 2030 or 2050. And so, of course, SAF has been the answer for the majority of the aviation industry, but they're also not even, not only thinking about the fuel side of the business, but also they're looking for a step change in unit economics as far as the operational side and the efficiency side of it. And so the blended wing body actually makes a lot of sense for cargo. Specifically for the same weight of airplane, you can introduce almost 2.5 times more volumetric capacity. And so in layman's terms, what that means for our airline customers is that you can carry almost double the amount of revenue cargo for the same trip. So as traditional tube and wing airplanes are cubing out on volume before on top on weight, now the maximum gross weight or the payload weight of the airplane matches what is actually volumetrically is capable of carrying. And the second piece of the puzzle is, of course, the efficiency gains with the blended wing body. Traditional tube and wing configuration will have about 90% of the lift coming from the wing and 10% on the fuselage. With the blended wing body, you have almost 40% coming in from the fuselage and 60% of the wing. And so you need smaller wings, as an example, more aerodynamically designed fuselage. And so that contributes about 30% reduction in operational costs, specifically just due to aerodynamics. And so when you couple that even with more efficient engines, specifically even lower thrust engines, you're actually able to squeeze out almost a 50% reduction in operational costs for the same trip. So more cargo, double the amount of revenue cargo, but also more efficient operational side of the business, as well as the matching of the sustainability goals. And so that's why Natilus is very excited to be working on a family of airplanes to bring the blended wing body back for different pieces of the supply chain.
Okay. Now, with the efficiency and also the lower powered engines, are we looking at a cutback in speeds, or is it still just going to be an even trade?
Even trade.
Okay.
So, engines usually size for takeoff thrust, where weight is a huge factor on the airplane. And so we're able to reduce the weight of the airplane while still kind of making sure that the revenue cargo is still the same. Mm-hmm. And so that's really what allows us to scale back the engines, but still maintain speed.
Okay, great. So I've talked with Dave Darius about the Sabre wing, and that seems to be more geared towards the regional air cargo. So the larger aircraft that you have, is that more international type cargo travel, or just cross country, or where do you foresee it in the future?
So Natilus is actually a family of 3 products. So Sabre Wing is starting out in the lower payload category, shorter hop flights. We have a product that's a little bit above them in capacity, but different type of mission requirements. So Sabre Wing is focused on eVTOL. They have a hybrid drivetrain, focused on those really hard to reach places. Our first product is the Kona. It's a 19,000-pound Part 23 airplane capable of carrying about 4 metric tons of capacity, fitting in between 12 to 7 standard air freight containers, which is really important to our customers. Typical flight times are 240 knots, or about 1 to 2 hours, but a lot of our customers might be able to use that airplane up to 8 to 9 hours to 900 nautical mile range. And so really the mission of that airplane is connecting the smaller regional airports where infrastructure does exist currently
Mhm.
to the larger hubs. So a good example might be Eugene, Oregon to Oakland for the FedEx nightly sort, or connecting, the southern Japanese islands to the mainland Japanese island as well. So those are kind of like the mission requirements for the first one. The second product is a 60-ton freighter, most closely competing with the 767 and the A330 products. That'll be North America, transatlantic, inter-Europe, inter-Asia. And then the flagship product, the one that gets everybody excited, is the 777 long haul delivery replacement, almost 5,500 nautical mile range, essentially connecting 2 points on a global level.
Okay, great. Um, Looking forward to seeing it now. Now you're looking at an autonomous configuration rather than a crewed one. I know, are we looking at establishing pilot stations with the potential users of the aircraft, or will that all be within Nautilus?
No, we do not want to operate the aircraft for a variety of regulatory reasons and business decisions. It doesn't really make sense for us. So we are strictly a manufacturer, OEM, design, build, and sell our airplanes. We leave the operational side of the business over to the airlines. And so as we think about the remotely pilot or teleoperations for our aircraft, it's really the customers that end up setting up the centers using our equipment,
Mhm.
which connects to the aircraft for that phase or leg of the technology.
So how much are you involved in helping them set that up? Are you just going ahead and building the remote centers that they can purchase or rent as necessary and then operate?
Well, the remote centers in our perspective are really is a desktop computer with a mouse and a headset. And so the equipment is really basic. There's redundancies within the hardware just to make sure if there's a power outage or something like that, there's obviously operational and data link involved in that.
Okay.
So it's not the data center looks very much like a normal, I would say, workstation in many ways. And so the way that our customers are thinking about it is a dedicated office room, essentially with TSA clearance, so you can go in there obviously for control and security reasons. And then as you enter, there's just work desk solutions with headsets for the remote pilots.
Now, will they be formally trained pilots or just uh, remotely operating without any much of the other normal pilot training that we receive?
So the way that the FAA is approaching the new regulatory base, which opened up in 2013 to start out with, is you need exactly the same qualified pilots in the remotely piloted desks. And so that's very important for them as they kind of scale up into the technology. We envision, obviously, that the qualifications will be reduced because the technology is doing a lot of the work in the first place. As an example, the airplane flies itself, the remote operator nearly guides it through the national airspace system. And so we think that as this technology gets proven out, makes its way into the market, that we can reduce the qualifications of the pilot and then really address the big pain point for a lot of our feeder freight customers, which is the lack of pilots entering the workforce.
So that's one of my hopes is, okay, I haven't been able to build up the hours to get one of those jobs. Maybe I can get in with fewer hours and build them remotely.
That'll be a very interesting story. So we're exploring that story with our customers as well as the regulators right now.
Okay, great, great. Um, Anything that you would like to that we haven't already mentioned? I like to said, like I said, I like to leave it open to you guys to tell your story. When do you think your your first vehicle, a prototype or actual, will be ready to be seen?
Yeah, so the company is about 26 months, 24 months away from getting to first flight. That'll be a full-scale prototype of the Kona, and that'll be an 85-foot wingspan, 19,000-pound blended wing body. To our knowledge, it'll be probably one of the world's first blended wing bodies when it sits on gear, which will be really exciting. There's a lot of challenges on the technology that have been talked about by both NASA and the McDonnell Douglas in their technical papers.
Mhm.
Surrounding the stability and control of the airplane being probably the first and foremost, as well as the gains in efficiency, which we kind of hinted upon as well, which we validated through our kind of analysis. And then lastly, it's the pressurization. So it's a really good I think entering to the market where it's an unpressurized airplane, so we'd have to deal with that to start out with. It's meant for the freight market, which kind of takes away some of those other questions about egress and things like that. And then lastly is the stability and control. So Nautilus we spent quite a bit of capital, of our own capital, doing a lot of research and development in a local wind tunnel. So the San Diego wind tunnel is one of the old Convair facilities here in town. And so we've done 3 wind tunnel tests there to help address the challenges of creating complex flight control systems and laws in controlling the blended wing bodies. So we've been able to solve those challenges through the use of clever aerodynamics. And so right now you can fly the airplane completely open loop or a pilot cam without the use of any overriding autopilot features. And so it flies almost exactly like a Beech King Air, which is really exciting for us that we've been able to solve those key technology challenges, and we're able to then scale them up into the first flight and really prove them out.
Are you guys looking at building it all in the San Diego area, or do you think you'll have manufacturing someplace else and just leaving the headquarters in San Diego?
So it's a great question. Research and development, as far as getting us to first flight and keeping the engineers kind of close to the product, is where San Diego plays a huge role for us. Specifically, having the wind tunnel facilities here. A lot of our suppliers and talent pool comes from the Southern California area, which is great. And then also we're based out of a brown field, which is an 8,000-foot runway, which is just really great infrastructure for us to grow. So in the near term, we're definitely sticking around San Diego, and we're really excited to grow our presence here. But for the production version, of course, there's a lot more workforce that is needed, different types of facilities as well. And so we are looking at possibly disconnecting the production facilities from the engineering facility here in San Diego, looking at a variety of places here in the United States. A lot of advantages of states giving to us as far as tax breaks and, helping us grow these, essentially this production facility for a variety of reasons. As we all can tell, probably California is not the best place for offering incentives to growing a large scale company such as ours.
Yeah. Well, I used to work for Boeing, so it's like, yeah, okay, we're doing this here and we're building everything up in Seattle or Wichita or something like that. So
there's a lot of disadvantages in that, unfortunately, and it's really unfortunate from that perspective that you increase the timeline to market and things like that. But as you ramp up production, as long as support for manufacturing engineering kind of stays with the production line, I think R&D has the capability to kind of be on its own. But yeah, not ideal by any stretch of the imagination.
Oh yeah, but Boeing had both military and commercial, so they could separate it like that. Okay, great. Well, I am truly enjoying it. Maybe I can do another follow-up story in person, especially when we get to see the prototype and take a walk around the full-scale version.
Yeah, absolutely.
So, and it sounds like a couple years, Oshkosh, because they always bring in their big airplanes to show off too.
Yeah, absolutely. We would love to eventually bring in the first prototype, the Kona, over to Oshkosh and Sun and Fun. I think it'll be eye-opening to a lot of the general aviation market, of course, but just in general, it's so big. We're already starting to see some of the pieces, at the facility, and it's just eye-opening how big this thing is going to be.
Thank you very much for spending some time with us today. I know you got a busy schedule. Thank you once again. And everybody, this is Brian Purdy with the Florida Aviation Network. Have a great day.
Thank you, Brian.
Thank you.